Good morning. Our lesson today is about Newton's laws. Newton's laws. First law, Newton's first law, Newton's second law, and Newton's third law. This is the first part. The second part, we are going to review about uniform rectilinear motion and uniform accelerated rectilinear motion. Starting with the Newton's first law. First, we have to review that Newton's first law states that sum of forces external equal to zero. When the sum of forces external equal to zero, it means that when a body is at rest, it stays at rest. When a body moves with the same speed or with a constant speed, it continues its motion with a constant speed, then its motion is URM. So when sum force external equal to zero, we have two cases. The object is at rest or the object is in motion. When the object is at rest, then V equals zero. When the object is in motion, it moves with URM. As a revision for URM, we have if an object is moving a constant speed with a constant interval of time, then we have V equal constant. V equal constant, then acceleration equal to zero, then the type of motion is URM, then time equation for position is x equal vt plus xe. This is for Newton's first law. According to Newton's second law, if a body of mass m is subjected to several forces, يعني sum of forces external, it moves with an acceleration a of the same line of action and direction as f such that sum forces external equal ma. As an example, we can take an object S moving under the action of a force F, weight mg, and normal n. We have to choose a positive sense of direction E along F. If we want to find normal and acceleration, first we have to apply second law of Newton. Second law of Newton states that sum of forces external equal ma, then F plus n plus mg equal ma. To find normal, we have to project along y-axis, and we have to suppose that y-axis is here. And to project along, to find acceleration, we have to project along x-axis. First, to find normal, project along y-axis. What are the forces along y-axis? We have normal, suppose that this is the origin. Normal, upward, it is positive, and weight downward, it is negative. Then n minus mg equals 0. Why it is 0? Since no motion along y-axis. The object is not moving vertically. In this case, we have n equal mg. Now, to find acceleration, we have to project along direction of motion. It's x-axis. Direction of motion, it means that we have only force acting along direction of motion is F equal m times a. Why we write here m times a? Since there is motion along x-axis. In this case, we have the acceleration equal F over m. Now, we have to study the type of motion. To study the type of motion, we have to find the acceleration. If it is positive and constant, then the motion is UARM. If A is negative and constant, then the motion is UDRM. In both cases, we can use the time equation for position. Vx equal half at square plus v0t plus x0, and for speed v equal at plus v0. Now we are going to solve an example about Newton's second law. Suppose that we have a car of mass 1,500 kilogram moves under the action of a motive force. Motive force means it is a positive force along direction of motion, 7,500 Newton on a rectilinear and horizontal road. At t0 equals 0, the car starts with 5 meters per second. At t1 equals 10 seconds, the distance covered is 200 meters. Knowing that friction forces exist and of magnitude 1,500. Number 1. Name and represent the forces acting on the car. They are represented already. We have just to name them. We have here the normal, and we have friction force Fr. We have weight mg, and we have the motive أو attractive force اللي هو F. Second question, apply Newton's second law to calculate the acceleration. We have to find the acceleration. Newton's second law states that sum forces external equal ma, then N plus W plus F, N plus W plus F plus Fr equal ma. Before we continue, we have to choose a positive sense that is given. It's along V. This is the positive sense. This is the x-axis. Suppose that this is the origin. Everything in front of the origin it is positive, and behind the origin it is negative. Then, to find acceleration, we have to project along direction of motion. To project along direction of motion, we have F, it is positive, Fr, it is negative, equal ma. Then A equal F minus Fr over m equals 7,500 minus 1,500 over the mass is 1,500. It is equal to 4 meters per second square. This is the acceleration. Part 3, specify the nature of motion. Since the acceleration equal 4 meters per second square, it is positive and constant, then the motion is UARM. Finally, calculate the velocity or the speed and the distance. Since the motion is UARM, then we have V equal AT plus V0. This is for the velocity, and the distance x equal half AT squared plus V0t plus x0. Let's start with the speed. We have V equal 4 times 10. Since at T1 هي 10 seconds, plus V0 اللي هي given 5, then V equal 45 meters per second. To find the distance, x equal 1 over 2 times 4 times 10 squared plus 5 times 10 plus 0. Since x0 is the origin of motion, it is 0. Then x equal 250 meters. The last idea here we have in Newton's third law. Newton's third law. Suppose that we have two objects, object 1 and object 2. This is object 1 and this is object 2. According to third law of Newton, object 2 is holding object 1 and object 1 is putting its weight on object 2. Then, this is the force exerted by 2 on 1 and this is the force exerted by 1 on 2. Then we have F1 on 2 equal minus F2 on 1. Then they have same line of action